This video is about forward and backward difference interpolation. We will study this topic in connection with the Newton divided difference interpolation. So let's have a recap that what we have discussed so far in this lecture, before this lecture. So polynomial interpolation problem, curve fitting, regression and interpolation, and why we use polynomial interpolation are the things that we have covered in the very first video. Then we have covered the Lagrange interpolating polynomial and Newton divided difference. So the major topic of today's video is forward divided difference polynomial. We have discussed the polynomial problem where we have to fit n plus 1 data points with a polynomial of order n, and then using that polynomial we can find the intermediate value which is required for the problem. We have done the Lagrange problem. Just a review of that. In Lagrange we try to find L0, L1 and Ln. Formula is given here. In Newton divided difference, we try to calculate A naught, A1, A2, and we do it with the help of table. So in forward divided difference, we'll be using equally spaced data to the Newton divided difference. So what will be the advantage of this? We will see in this video very soon. Basically, we will try to find an expression for this f with a square bracket and then xn minus 1 and so on, and the product of these. So we will try to simplify this with the advantage of equally spaced data. So what is equally spaced data? In the first picture, we can see that data points are given. Some are close to each other, some are very far from each other. So this data spread is not equally spaced data. Whereas in the figure below, we can see that the data points are equally spaced. So what do we mean by equally spaced data? We basically see the uh, distribution on the x-axis. If the x-axis distribution is even, then we say that it is in equally spaced data. Suppose x data values, which are called node at sometimes. Uh, Suppose that these values are x naught, x1 and xn are given, and they are equally spaced, means the distance between any two consecutive point is the same. Then we say that the data is equally spaced data, and it will look like this, that the difference or the distance between any two point will be the same, delta x. We can see that in case of x1 minus x naught or x naught minus x1, absolute value make no difference. But when we consider the function along this condition, then there is a major change, or the derivative comes into the play. But here we see that if we take a value f of x and a forward value f of x plus delta x, then the resultant or the forward difference, which is shown by the blue line, is in this direction. If I take the backward difference, then it becomes another direction. And there is a term called the central difference, which we will not cover in this video. It gives something else. So it is important that which difference we are taking into the account. So forward difference operator, which is denoted by delta, and the backward difference operator, which is denoted by nebula, are defined like this. Forward difference operator delta f of xi, or we may simply write delta fi, just a short notation of f of xi. So in delta f of xi, it is the next value f of xi plus 1 minus del f of xi. So it is a difference between the forward value. So that's why we called it a forward difference. So in case of backward difference, The formula is given here. It is the difference between f of xi and the previous value f of xi minus 1. So these are the two operators. One is called delta, other is called nabla. So what can we simplify in terms of x? So here we can see that our data is equally spaced. Equally spaced mean x1 has, if x naught is initial point, then x1 is at the same distance from x naught. Let's say this distance is h, then uh, distance between x2 and x1 is h. So if I consider the distance between x naught initial point and the second point, then it becomes x naught plus 2h. So if x naught is an initial point, x1 is first point, then it will be x1 will be at a distance of h, x2 will be at a distance of 2h, x3 will be at a distance of 3h from the initial point. So to write the distance or to write the expression in mathematical form for these equally spaced data, I can write x1 is equal to x naught plus h, x2 is equal to x naught plus 2h, x3 is equal to x naught plus 3h. In general, xi is equal to x naught plus ih, where I is an integer number. But in case of interpolation, we want to find a value which is different from this data point, means which is in between any two values on the x-axis. So let's say it is x, then how can I write x? I can write x naught plus sh. Here s will not be an integer. If it is an integer, then it will be a data point. So it must not be an integer. And we can calculate s is equal to x minus x naught over h. So this is the point which we want to locate. And this expression s is equal to x minus x naught over h, because in general cases in the problem we are given with the value of x initial value and the difference between the values, so we need to calculate s. So what we have obtained so far, that in equally spaced data the distance between any two consecutive point is denoted by delta x, or sometimes we write it h, and distance between x and x naught is denoted by sh. So with the help of these, we can write the distance between x minus xi between any point is given by s minus I into h. So why we are doing this? Because we want to write the product which was in the Newton divided difference in some form, in some simplified form. So we can see that using the equally spaced data, we can write the product of x minus x naught and x minus x1 in the form of s into s minus 1 into h square. For the three factors, it will be s into s minus 1 into s minus 2 h cube. So for 4 factor, it will be h4. For n factor, it will be h n, and s minus 0, s minus 1, s minus 2. So this is how we can write it like this. If there are if there are four terms, we will get a 3 here. If there are n term, then we will get n minus 1. And because of the minus outside, it will become s into s minus n plus 1. So from here, we will we will simplify the formula. We will simplify it with the binomial coefficient. So first of all, I will drive what is I will review what is binomial coefficient, and then we will use it. So binomial coefficient, if we call it NCR as sometime, and in this case, S CK. SCK is S factorial divided by K factorial into S minus K factorial, which simplifies in this form. So our S into S minus 1 kind of things become K factorial into SCK. So This is the simplified form which we can use, and you can write s into uh, sc1, s into s minus 1 into 2 is equal to 2 factorial sc2, and similarly for 3 term and for 4 term and so on I can write this. So using this, the product term which was appearing in the Newton divided difference may be written in s into s minus 1 into s minus 2 up to s minus n plus 1 h power n, and by using the binomial coefficient we can simply write it k factorial into s c k. So if I write it for k terms, then I can write it like this, and I can see that here is a power, h has power k. So there will be k factorial s c k h power k. So all the product term may be written in case of binomial expression like this. So we have simplified one thing out of two, that the product. This was the Newton divided difference, and we can see that there are product term appearing in each term. So we can write this above function in compact form like this. So if I is equal to 1, there will be only one term, and uh, if I is equal to 2, so we can write this in the compact notation like this, and we can further simplifying the concept of equilibrium data, that this product may be written as k factorial into h power k s c k. So if I use this in the above Newton divided difference polynomial, then the things become like this. Just using the value of the product terms here, it will eliminate all the x values, and it will depend upon s and h only. Now what to do with this term? So here we will use the difference operator, and we are going to do it for the forward difference operator. As we defined, forward difference operator is uh, there should be a plus sign here. It should be a plus sign, because the forward difference is the thing in which we consider the forward value and subtract x from that forward value, and uh, s- in simplified form, ignoring x, I we can just write I with it, and you can see that it is fi plus 1 minus 1. So there are many things to note at that difference, forward difference of f naught may be calculated at f1 minus f naught. F forward difference of f1 is calculated using f2 minus f1. Forward difference of f2 calculated is calculated there. I'm sorry for a mistake again. Here should be, we should have a 2 here, because it is the difference of two consecutive value. It is the first difference. So how can I calculate the second difference? I can calculate the second difference by operating this operator twice. So if I operate it first, it is f1 minus f naught, and if I operate it again, it will be df1 minus df2. Using the values from here, I can write, because I have to do a negative and a plus sign here and then add them, I'm going to get this. This is just to show you that uh, second difference of f naught is not equal to the uh, not equal to the first difference of the function. So in general, this is true that these are not the same. So if I try to solve the divided difference kind of a thing, then I know that the formula is f of x1 minus f of x naught divided by x1 minus x naught. X1 minus x naught is simply h, because the data is equally spaced and the distance between the 2 points is h. So this is the first, or the zeroth order difference. Zeroth order difference may be written as this, and it is according to this definition which we developed for f naught. This thing is equal to delta f naught. So we are left that the first difference is equal to 1 over h into delta of f naught. We can drive some more expression to get familiar with the terminology and get familiar with the operation. F of x1 x naught is equal to 1 over delta f of x naught. F of x2 x1 will be 1 over h delta f of x1, and similarly f of x2 x3 will be 1 over h forward difference, or the delta f of x2. So this was the first order difference. What about the second order difference? F of x2 x1 and x naught, we know that from the Newton divided difference, we know that this is equal to this. So here is a difference of 2h, so I can write it 2h, and we can simplify the things from here. I know that the first difference between x2 comma x1 is 1 over h delta f of x1, which we have done on the previous slide. This is, I'm talking about this, the middle equation. So I can write this, and similarly in the first x1 and x naught, it is equal to delta f of x naught. H I have taken 1 over h, I have taken common, so I can take the delta common, and this thing is equal to delta of f naught. So what is the expression for the second order divided difference? It is equal to 1 by 2 h square delta square f of x naught. So if I use these values, then what will be the third divided difference? Similarly, proceeding here, in this case, it will be 1 over 3h, and I have used this formula here at both places. So by using this formula, I can simplify the thing that third divided difference will be 3 factorial h cube over delta 1 over 3 cube 1 over 3 factorial h cube into delta cube f of x naught. So if I summarize the thing, I can write that the product can be written as k factorial dot h power k into s c k, whereas these differences may be written as 1 over k factorial dot k into dot h power k into difference of order k f x naught. So if I use all the thing in the Newton divided difference, then I see that the term k factorial into h power k cancels out at both sides, and from here we left with sck, and from here we left with the difference part. So this is the variant which will help us to find the data, find the polynomial for equally spaced data. So if we are given with the 4 points, then how can I write the formula? 4 data values mean n plus 1 is equal to 4, or n is equal to 3. So n plus 1 is equal to 4, I'm going to get a polynomial of degree 3. So that's why we have written a 3 here. X is equal to x naught plus h. So f of x naught and summation I k varies from 1 to 3 s c k delta power k f of x naught. So for 3, I can write k separately for each term, and this is going to be like this. S can be found with the help of x minus x naught divided by h. So let's try to solve an example. Data is given to us on for these points, and what we have to do, we have to find a polynomial where s can be calculated like this: delta f naught, delta square f naught, and delta cube f naught are the thing which are required to us, and we can calculate them with the help of table. So I can write the given point like this, and first difference will be f1 minus f2. It will be simply the difference of these two terms. So I can calculate the difference of these two terms, this term minus this term. So in the calculation of next, we will having the difference of next two term and the next two term. So I can complete this table like this. So these are the result, and similarly I can calculate the next value delta square f naught with the help of previous two values, delta square f1 with the help of previous two values, and sorry, delta square f1 with the help of previous two values, and then delta cube f naught with the help of the column mm, before the delta cube I. So in this way, the table will be calculated, and you can see that here we are just taking the difference of the values. So if we have table, we have the formula for it. We can just find S and insert the values in the table. So x naught, x is equal to 0.56, where we want to calculate the value h is 0.5. You can see that the difference between any two value is 0.1, and x naught is equal to 0.5. So s can be calculated like this. So if we have s is equal to 0.6, we can put this it in the equation and get the value of the polynomial which is required here. There are some further properties of forward difference that you can explore, but the major thing here is that can you repeat all these things with the backward difference operator? This will be a task for you. This will be an assignment for you to complete this task. If you have any questions or query, you may contact me with my email given here. Thank you very much for today's lecture.